Good afternoon and welcome to the Internet of Manufacturing. My name's Doug Drinkwater, I'm the editor of Internet of Business and delighted today to be joined by Richard Soley, the Executive Director of the Industrial Internet Consortium. Welcome.
Thank you very much. It's a pleasure to be here. Great event.
Talk us through then what you've been doing with the Industrial Internet Consortium. You spoke earlier about the partnership with Industry 4.0. I know you have a number of test beds ongoing, but talk us through a bit about what you've been doing these past kind of 18 months to 2 years.
2 years, in fact. So we were founded on March 27th, 2014. So today is 5th of April, 2016. We're almost exactly 2 years old. Our focus has been since the beginning on building test beds, not standardization, not promotion, but building test beds, because test beds are the best way to learn how the Internet of Things technology can disrupt markets, can change the way vertical industries build systems, run their systems, and get value from those systems. We have 15 test beds that are publicly described on our website now, and a number of them that are under development and are not yet publicly described. And we have about 15 or 20 test beds that are in development that you should see and hear more about the balance of this year. The idea is these markets are going to be disrupted, whether they're banking or mining or healthcare or manufacturing or transportation and logistics. They're going to be tremendously disrupted over the next few years. So these companies have decided that rather than wait and see how their markets are going to be disrupted, they're going to disrupt the markets themselves. As Steve Jobs used to say, the best way to predict the future is to invent it. So 5 companies founded the organization March 27th of 2014, as I said. In the first year, 100 companies joined us, and now 150 more, so we're well over 250 member companies from about 30 different countries. They're in all sorts of technology areas and research areas, but most importantly, users of the technology that realize that manufacturing is going to change, healthcare is going to change, transportation and logistics are going to change, asset management is going to change, and they want to build test beds to learn how they're going to change. So they can figure out what's the best way to use this technology and how does it affect my profit and loss, how does it affect the way I report to my shareholders, how does it affect CapEx versus OpEx. All those questions are really difficult. Of course, we're not the only organization that's doing that in the world. Most other organizations are focused on other parts of the problem, but we have discovered that especially here in Germany, there's an organization called Plattform Industry 4.0, Industry 4.0, which has been focused, I don't think it's 4 years now, on describing what that future is going to look like, writing excellent white papers on that topic and so forth. And as you know, 3-4 weeks ago, we announced a collaboration with Platform Industry 4.0. We're working together on architectural frameworks. We are talking about working together in other areas, including test beds.
Now, when you were speaking at dinner last night, one point I found really interesting was on the test beds, and you were saying they don't have to be a success, they can be failures. Talk us through why that approach, why most people would see that as surprising.
One of my favorite authors teaches bridge design. He's a bridge designer himself. His name is Henry Petrosky, teaches in North Carolina in the States. He wrote a book which is called To Engineer is Human. He points out that if a bridge stands, you've learned nothing, but if it falls down, you know that that design with those materials in that location doesn't work. So failure is an important and critical component of success. So I don't actually view failure as failure, I view it as a learning process. So we build these test beds and we hope that there will all be successes, but we assume that if you're going to disrupt markets, you're going to find disruptions not necessarily where you expect them, and that some places that you do expect to see disruptions, there won't be any. So we build these test beds, and if there are successes or there are failures, we learn from that test bed development process. These are obviously not product development processes, but the companies, the organizations, the research institutions participating in the development of those test beds learn something about how IoT can be applied in those industries, and they learn something about how IoT is not applied in those industries. So failure or success, we learn from those test bed processes.
And what kind of sectors have you seen? You mentioned a few there, health included, obviously manufacturing. What have been surprises for you? I mean, for example, you mentioned banking earlier, which seems to have less traction potentially at the moment. But what sectors do you see as the really surprising ones that have shot to the fore when it comes to industrial IoT?
It's really funny you say that finance was not a good example. I have been peddling this idea for a long time that somebody should track every trading desk and every stock exchange in the world simultaneously and use that data to benchmark against November 1929, October 1987, September 2008, major market crashes, and say this trading pattern looks like the market is going towards a crash and we should either slow the markets or close the markets and so forth. It was pointed out to me that these things already exist and they're called HFT, or high frequency trading systems. So I think the banking and investment world is probably further ahead than you expect. We're seeing the most interest in three areas: in manufacturing, where our first test bed was in, managed by Bosch, Tech Mahindra, and Cisco. It is attempting to do no less than reinvent manufacturing floors, how the floor is optimally used and with real-time information about the location of everything on the factory floor, but also ensuring that the factory floor is safe by keeping track of where the people are and making sure they're doing safe things. Second, electric power grids. I think nobody is surprised that but there's tremendous interest, and we have a test bed that's operating in Southern California. The first test bed I should mention is primarily in the Berlin area, although it's being rolled out to all Bosch manufacturing plants worldwide, 250 plants, and to some of their customers as well. The second one, called Command and Control, is about smart electric grids. That's in Southern California. They're moving some of that effort to Texas as well. And the third, and we've had overwhelming interest in the area of smart cities. So we have a smart cities project now in County Cork in Southern Ireland that integrates the national information technology resources in the country of Ireland with the provincial resources in the county, with the city resources in the city of Cork as well. And there are all sorts of things that you can do with that. For example, optimize the use and delivery of ambulance services throughout the county. But they will be doing everything from road repair to anything else you can think of as city services or county services or national services. We have another smart city project going on in Mysore in India for water management. We have precision agriculture projects, asset management projects, all sorts of projects. And as I say, the first 15 are listed on our website at iiconsortium.org.
What I found interesting when we were chatting last night was how these innovators can come from anywhere, and I think you mentioned again today actually the Costa Rican dairy farmer that improved its productivity or efficiency by 40%, and we've seen that also on IOB with connected cows and other areas.
Cows, yeah.
I mean, they really do come from the left field, you could say. But why do you think that is, that we're seeing these surprising case studies that kind of with industrial IT that come out from nowhere?
I think because the technology is easy to use. The problem with IoT today is that it's getting enormous amounts of hype, enormous amounts of visibility. And that unfortunately creates the idea that this is just another hype idea like distributed computing or service-oriented architecture or all sorts of other things that come and go in the IT space. And trust me, I'm well aware of them. I've been in the industry for a long time. But in fact, underneath the hype, there is something real here, which is actually making a difference. So Lecheria Santos, which is the dairy farm in northwestern Costa Rica, in the province of Heredia, that's the one you're talking about. They monitor their cows. There's actually a big hunk of electronics that's plugged into the right ear of every cow in the farm. And Mr. Urbina actually measures constantly on a second-by-second basis the health of his cows, whether they're pregnant, whether they've recently delivered a calf, what they've been fed, and so forth. I've learned so much from him. So the average cow weighs 600 kilos and eats 60 kilos a day. And the quality and amount and content of milk that they provide varies based on as little as 1 gram of feed difference. So they're differentially fed. How do you know which cow? By the thing in its ear. How do you know its health? Well, you've got the health history going back to when the thing was plugged into its ear. He actually buys that service from a company that has all that information in the cloud, a Dutch company in fact, and he in Costa Rica is able to use that technology from anywhere. IoT is nothing new, but it is this convergence of low-cost computing, low-cost storage, ubiquitous connectivity, and cheap connectivity, so that it no longer matters where something is or how big it is. You can get access to connectivity anywhere, use that connectivity to get access to compute power and predictive and preventive maintenance analytics anywhere in the world. That's the big change, this convergence of forces.
What do you see? You mentioned the hype. What do you see as the big challenges for IoT going forward? There's a lot of talk about that here, about standards, for example, security gets mentioned quite a lot. And I guess the hype itself can be potentially distracting from the ultimate goal of what a company is trying to achieve. But what do you see as kind of right now as the big challenges?
So the two factors that everyone talks about are, in fact, standards and security. The issue is nobody really knows exactly what standards to develop, and that's why we're building test beds, so that we know what standards actually are needed. For example, from the Bosch Tech Mahindra test bed, we've learned that we need semantic descriptions of manufacturing devices, so that devices from Bosch, but other manufacturers as well, can be integrated intelligently. So actually, Bosch has delivered the requirements for those standards to the Object Management Group, standards organization, to develop semantic standards for manufacturing devices. Interestingly enough, they've also delivered those requirements to Eclipse Foundation to develop open source implementation of standards to make it very easy to move into that space as quickly as possible. So standards, that's being addressed, and testbeds are a big piece of that. Security is also being addressed. So one of the things that we're doing is building a security framework. We'll be talking about it at Hannover Messe at the end of April 2016, and we'll be publishing later this year a security framework. But we'll also be attacking our testbeds with the knowledge of those testbed developers and with the intelligence of our security team, because we want to learn what kind of security we need to make sure when those testbeds are turned into real rolled out products, they are secure implementations. Look, the reality is, the history of the ICT world is, even if the systems are not secure, they're still going to be rolled out. So it's our responsibility to make sure that we've secured them as much as possible. You can never get to 100%, but you can get a lot closer than where we are today in the open retail internet. Where the hype becomes a problem is there is a cost of change for any kind of change. That's why people make money as change transformation consultants, especially when there is already sunk cost. So, for example, when there's enormous capitalization already been spent in manufacturing devices, or in cow milking devices, or in logistics trucks and lorries and so forth. So, we have to get past that, and the hype doesn't help with that. Unfortunately, there is capital cost. The good news is that we've minimized capital cost when implementing IoT, because you can take an operating approach. You don't have to buy a new jet engine. You can lease an engine from the likes of Rolls-Royce or General Electric today. That business model exists today. And that's going to be true for many, many, many other expensive devices. Now there's a downside as well, because those companies which used to sell and report capital sales will now be reporting operating sales. And the numbers look smaller, but they look a lot longer. From a cash flow perspective, they're a lot better than a capital sale, in fact, but it changes your books, changes the way you talk to and report to your shareholders. So that's the job for the transformation people.
It's interesting on the changing business models point of view, because Cone Cranes was obviously speaking earlier about how they changed their business model to more premium cranes, which they could obviously monitor as well. Do you think most companies are aware of the need to change their business model, or the potential that IoT can bring in that regard?
I don't know that they necessarily have to change their business model. So you're talking about the need. I think it's the opportunity to change their business model. As the great bulk of companies, because there's a bell-shaped curve for every new technology adoption, as the great bulk of companies make those business model changes, then they will have to, because the competitors will already be doing it. So jet engines are an example of that. As I said, a couple of jet engine companies are leasing their jets rather than selling them. Eventually they all will, because it will be a competitive differentiator. I think what they're not aware of is the opportunity to change their business model to this outcome-based economy idea. Accenture, I think, invented that phrase, the outcome-based economy, because you're buying outcomes rather than buying the device that delivers the outcomes. For example, jet engines, or compressed air. Compressed air is the case that SAP likes to talk about. And it's up to us to ensure that that change is not just a technical change, but we recognize how it changes the way you report to your shareholders, to your stakeholders. It has an effect on your accountants as well as it has on your technical people.
And I know you guys did a report recently on the kind of essentially where companies are at the moment with industrial IoT. Where do you think we'll be, a year down the line from now in terms of adoption and the market maturity?
Well, According to every report I've seen, whether it's from Beecham, so I was talking to Robin today, or whether from Gartner or Forrester or IDC or anyone else, we've gone in only 2 years from 10% implementing IoT and 90% wondering what the heck it is, to today 90% implementing or implementing within a year, and 10% ignoring it for now. So we're starting to climb that adoption curve. We're probably not at the center of the curve yet, but we're approaching it. I think any company that a year from now is ignoring the disruption that comes from IoT will not have to worry about disruption much longer, because they'll be disrupted right out of business.
Richard, really appreciate your time. Enjoy the rest of the show, and I'm sure I'll see you around.
Thank you very much. It's a pleasure.